Hello everyone, I'm Yusuf Kemal Planalı from İTÜ Vocationally and Anatolian High School. Today we will be talking about what a servo motor is and how it works easily with Arduino card. I will try to explain you guys step by step. So let's start. Let's take a closer look. What is a servo motor? In short terms, a servo motor is a motor that can control movement with great precision. It's not a standard normal DC motor. It's sensitive compared to other motors, other engines. It's used in robotic systems like robot remote controlled applications. It's uh, it's possible to adjust its position, speed, or torque, so it can be very useful in the project's unit sensitiveness or precision. We got three types of servo motors: the continuous servo, the micro servo, and standard servo motors. As you can see, let's look at what does change by the type of the motor. Micro servos, they're small sized, the smallest one on these three types. They rotate in a limited small angle, mostly 0 to 180. It doesn't run 360, it doesn't run 360 angle. It only runs 0 to 180 mostly, but sometimes even a tighter angle. They are mostly used in small robot projects, and we will be using micro servos in our projects with Arduino. Standard servos, they are mid-sized. They are not as big as the continuous servos, but they are not as small as the micro servos. They rotate in 0 to 180 mostly. They are used in robotic arms, RCV cycles, and automation projects. We got continuous servos. They are mostly big sized, the biggest one on these three mostly, but they have smaller ones also, like micro continuous servos. They can rotate any angle 0 to 360, and they're used in robot fields, rotating platforms, and moving mechanisms. And we have a very special topic here, PWM signal. It's very important. If you want to understand what a servo motor is, you gotta understand what PWM signal is. Normal electronic signals are transmitted as electricity high, like electricity present, and electricity not. High and low, 1 and zeros. However, the situation is different with a PWM signal. When we got the PWM signal here, you see it's not 1 and zeros. It can be found in a specific range. The situation is very different with the PWM signal. It's not zeros and ones. It can be found within a specific range, like 0 to 180, 0 to 360 in our servo motors. Servo motors are also used for precise operations, and their range is determined by the incoming PWM signals. That's why the signal we got here is very important to understand how does the servo work. If you want to understand how does the servo work, you gotta understand what PWM signal is. Okay, now we got the servo to Arduino connection. The red cable here, it's always the 5 voltage. Sorry. And we got the brown. It's sometimes black, but almost every time it's the darker one of the cable. The darkest one is the GND, the negative end, you can say. Now we made the connection with the plus, and we made the connection with the positive end, with the negative end. So the other cable is the controller, the one we will get the signal from the Arduino, it was a PVM digital pin. I will show you guys in the next presentation. The ones with the curve signal next to it, it's the PVM signal. Okay, here we got our servo and the 3 cables I told you. At the GND, I said the darker one, it's here. GND 5 voltage, it's connected to the servo, and we got the control cable. It's sometimes yellow, it's sometimes orange, but it's the mid one, I can say, yeah. So here we connected it to the 9 digital pin 9, but which ones could we have been connected it is 11, 10, 9, 6, 5, and 3. You can connect it with 4, with 2, 1, 0, 4, 7, 8, 12, 13. We got digital pins here. We got 0 to 13, 14 digital pins, but you can only use 6 of them in your servo projects with the PVM sign. It's important to check it if you are connected it with a digital pin with a PVM sign or not, because when you don't connect it with the ones with the PVM signal, it will not work. Now we got the Arduino codes. Today with the codes we will be using Arduino IDE program. It's completely free. You can download to your PC, you can download to your computer very easily. Let's look at our codes here. As I said, when you open the Arduino IDE program and a new page, a new coding page, this code right here, void setup and void loop, will be here. These are the codes that's given to you even if you don't add. So void setup, what does it mean? Setting it up. You set this code up means that you run it for once. You don't loop it, you don't run it every time. And what does it run? The code between this curvy bracelet here and this curvy bracelet here, the codes between them gets run for once. It does run for once, not more than it. So take a closer look at the other codes here. We got void loop, looping. It does run, it keeps running it again and again if it doesn't lose the connection. So it will work, and it will work anytime. It will run each time it runs it, and runs it, and again here runs it again. We got the curvy bracelet here. Sorry, wait a minute. We got the curvy bracelet here and here. They do run for again and again. They run in a loop. So I explained to you guys step by step what is the setup and void loop is. Let's take a look at the first, second, and the other codes. We got hashtag include. It means to add. You add what? Right next to it, this. It's a library, it's a specific library found in Arduino the program. It will already be downloaded in your device if you download Arduino the program, but to use in this code here, you gotta add include servo hash to servo h to use this code, this library in your code. So right under it we have Servo Hakan. It can change the name. You can change the name Hakan. It's a specific name. It would have been Yusuf. It would have been Kemal. And in most codes online you will see my servo. It's mostly it, but you can give any name to it you want, but it has to be written in English. So you can't type something like this. It will not work, or this. It will not work. You have to text it, you have to write it in English characters. Now let's continue. We explain to our device servo. The servo's name is Hakan. There's a servo named Hakan, and this Hakan here, we got Hakan here again and here again. So it means that when you write, let's think that its name is not Hakan. Its name is Yusuf. Our servo's name is Yusuf. The code right here, it will be like that. It would be like this. Or here it would be like this. So the only thing change is the name. The other ones doesn't change. When you change the name, you give your device, my servo's name is Hakan. So we explained our PC, our servo's name Hakan. But how will our Arduino know where to get the signal from? Here it is attaching code. Our servo's name Hakan attach 9. Means that connect means to connect your cable, connect the Arduino to the 9th cable. Neyse buraları keseriz. Okay. Okay, here we got void loop and we got Hakan right. What does mean? Right means to rotate. Rotate my servo called Hakan to the angle of 180. 180, the number here is the angle you want. When you write this, it will not work because our micro servos is capable of running only between 0 to 180 angles. So when you write this, it will not work. When you write this, it will not work. When you type something in minus, it will not work again. You have to write a number between 1 to 180. So what did this code did? We did add our coding line, the Servo H library. We named our servo Hakan. We connected it to the digital pin 9 and we rotated to the 180 angle. So let's get to the other line. Yes, the other code here. It may look very complicated compared to it, but it's not very different. They include servo hash. We did it before the other one. As I said, adding this code, the servo H library, and we named our servo again Hakan, and we attached our Arduino with the third digital pin. So as I said, you can only use 3, 5, 6, 9, 10, and 11 with your codes. So if it would be not 3, maybe something like 2, it will not work. You gotta add the numbers I said with the ones right next to it. It should it should look like this. We did the Hakan right. We did that. When you give 90, it rotates to 90 angle. When you give 0, it rotates to angle 0. But these are some differences. Like the serial begin code means to start serial communication between PC and the Arduino card. But what does the number in it means? How fast will our code run? How fast will be the connection between Arduino and our PC will? So we started our communication with our PC to Arduino and 9600 milliseconds. And there's also a different two codes again, delay and serial print ln. So delay means to wait. Why do we want our code to wait? Because when it doesn't wait, you can't see the process in your code. So if you want to see the process more clearly, you're adding delay. But it says 1505. So you're gonna ask, 1 seconds? No, not seconds. It means milliseconds. And milliseconds, for you to understand, milliseconds is only 1 second. So if you want it to wait for a second, you should wait 1000. Okay, and we got the serial prints ln code. We have two serial prints codes. Prints means to write it on my computer. Like if you write this code and run it properly in your PC, you will see this. Not this, sorry. You will see this. You will see this on your computer if it runs properly. But what does the ln stands for? When you don't write ln, it's writes, it's in the loop. You see, it runs like this. Let's say that we are writing the code, not Servo Junior here, the letter S only. If you write ln, and if you don't write ln, it will run like this, right next to it, and it will be hard to understand. But if you add the ln line, it will be line by line. You will see the process. You will see the text more clear, and it will be a better work mostly. Like if you use the ln code, it will be better. Now let's summarize what did we learn today. Today we learned what a servo motor is and how it works with Arduino card. We saw that servo motors are different from DC motors because they can move to specific angles, usually between 0 and 180, but as I said, it can run to any angle with continuous servos. We also learned how Arduino controls a servo motor using simple codes And why servo motors are very useful in projects that need precision, such as robot arms and automated systems. Long story short, servo motors are small, simple, but very powerful components in electronics and robotics. I'm Thanks for listening to me. My lesson ends here. Thanks for listening to me. My lesson ends here.